Hi folks. Okay, so what we're going to do today is talk about colour spaces. Yes, I'm sorry if you were looking for something that's going to be awesome and spectacular, this might not be your bag, but it is really super important that everybody understands about colour spaces if they are into photography. When we think of colour spaces, everybody thinks of ProPhoto, Adobe RGB 1998, or sRGB. And as you can see, sRGB is quite a small colour space, Adobe RGB is a bigger colour space, and ProPhoto is an even bigger colour space. These colour spaces are actually synthetic colour spaces. They are, to a degree, meaningless in the fact that they're not natural. They are not specific to any device, any particular device whatsoever. So they are truly synthetic profiles. ProPhoto, as you can see, is the largest colour space. And that is usually as far as people go. And then they start talking about the nuances of ProPhoto, and as you can see from this oft-quoted example image that you see plastered all over the internet, usually by people who are slagging ProPhoto off, which is a stupid thing to do. They have problems with the fact that it contains greens that are outside the gamut of human vision, and it contains blues that are outside of the gamut of human vision. The gamut of human vision being this, why do they call it a horseshoe? I've no idea, because seriously, if I owned a horse that had a hoof this shape, I'd be calling a vet pretty damn pronto. But this is the usual way that people portray the ProPhotoRGB colour space, the Adobe RGB colour space, and the sRGB colour space. It bears more relevance when you understand what it is in the background that they are comparing it to, and it's this, which is the CIE 1931 chromaticity diagram, or spectrum of human vision. And as you can see, it's quite an uninspiring thing, but the numbers around the edge, these are in microns, and usually the frequency or spectrum frequency range of electromagnetic energy for visible light is usually expressed in nanometers. And if you want to know how to convert nanometers, or convert microns I should say, to nanometers, knock the decimal point off and stick a naught on the end. So fundamentally human vision runs from 380 nanometers all the way round through from purples through blues, all the way round through greens, down to the most saturated red that we can see, which is 770 nanometers. If you want to know what this little black line is here, this is the Planckian locus. And you usually find that your D50, D55, D60, D65 white points fall on the Planckian locus. Other than that, I'm not going to talk about the Planckian locus because it's of no real consequence to us here. But the one thing as an interesting aside, you will notice where the little wordage descriptions are, wherever they figure the word green, or the colour green, so we've got greenish yellows here. This is equal energy red, green and blue. So this is where your Planckian locus falls. To greenish blue, if you actually bisect this CIE chromaticity diagram through the greenish yellows through to the greenish blues, you'll actually find that all this is twice the area of anything that's containing the word either blue or purplish blue through to red. In other words, the human eye is twice as responsive to green wavelengths of light as it is to red or blue. Something to do with seeing saber-toothed tigers loitering in the grass? I don't know. But yes, strange, we used to be prey at one time, not predators. And so, yeah, there you go. But that's not the interesting factoid. The interesting factoid is this. This is why you've got twice as many green filtered photodiodes or photosites on your sensor as you've got red or blue. That's if you use a conventional Bayer pattern centered camera. So that is the CIE 1931 chromaticity diagram, and so what I'm going to do is I'm going to remove that, and then if we scrunch that over and then sort of scrunch this up a little bit so we can sort of see what we're doing with both applications. There we go. So if I was to say swap out to the Adobe RGB color space because it takes up less real estate, you can't really compare this 3D gamut view with this diagram here. But if I swap out from a lab plot to a YXY plot, now you can see there is the same spectrum locus of human vision as we've got here behind these triangles. And if I was to flip this round, I don't remember how to do it, it's quite complicated. There we go, sort of like that. So if we look at the Adobe RGB color space, there are our greens, there are our reds, and there are our blues. Now here's the thing. You can see that the Adobe RGB color space does not maximize reds, greens or blues within the gamut of human vision. So that's okay as far as it goes, but you have to take into consideration when you're talking about colour spaces in which you work. These are the working space in your raw processor, and also your archival colour space if you use an archival workflow, which I know a lot of people do, but then again a lot of people don't, because they just want to process the raw files and then export them as sRGB JPEGs and get them up on the web or social media or whatever. But especially if you're into a archival type workflow, you need to be aware of the limitations of not archiving your images out in the ProPhotoRGB workspace. So I'm going to come to that now. So what I'm going to do is, hopefully you've got this now, how these triangles line up with the gamut of human vision. And so I'm going to minimize that, bring this back out, switch back over to lab projection to get rid of the spectrum locus, and I am going to first of all talk about output colour spaces for those of you who are into an archival workflow like I am in most cases. And so what we need to do is to look at a printer profile or printer colour space, and I'm going to go a bit flash here, and I am going to look at or take into consideration this colour space here. Alright, which is for an Epson SCP-7500 to 9500 printer. This profile is actually supplied by Permajet for their fibre-based distinction paper using Epson OEM ink. So this colour space represents all the colours that can be printed on that printer using this paper, fibre-based distinction, and Epson ink. Alright, and you think to yourself, yeah, well, what's this all about, Andy? Where's the relevance of this? Alright, if you were to archive your image out in the Adobe RGB colour space, so let's hold this for comparison and go for Adobe RGB. Now the coloured wedge is the Adobe RGB profile, but look at all the colours that the printer is capable of printing but are not contained within the Adobe RGB colour space. Now for some people that's not a problem, but they are not realising something. all these colours that are in the white wireframe but outside the coloured wedge, all those potential colours in there are colours that you've spent thousands of pounds getting access to when you bought your printer, your ink and your paper. And your lovely, carefully crafted image in the Adobe RGB colour space cannot make use of these colours here, these colours here. And let's look at what colours they are. They are orangey reds, alright, or orangey yellows. They are yellowish greens, yellowish reds, reddish purples and reddish blues. These are all colours that are present in various types of sunset image. So we can fundamentally get more saturation and more tonal range out of these colours on this printer than we can actually hold within the Adobe RGB colour space. That doesn't sound like a very good plan, does it? Because you've spent a lot of money buying this printer and you're not using it to its fullest potential. Alright? And so if we archive that image out in the ProPhotoRGB colour space, there you go. You can't see any of that underlying printer profile. Let's swap that out and say, oh, that's a comparison, and then go back to the printer profile. Now you can see that if you store your image in the ProPhotoRGB colour space, you will be able to maximise the colours that you are capable of reproducing with your printer. If you've got colours that lie within the ProPhotoRGB working space or storage space, archival space, but outside the printer profile, you have to bring those into the printer profile region with a process called soft proofing, and relatively simple. But at the end of the day, to allow you to get biggest bang for your buck out your printer, you want to archive out in the ProPhotoRGB colour space. Yes, you do. And the other thing that people who do videos on colour spaces fail to point out to viewers is on the other side of the equation, the workflow equation, and it's called capture space. And the capture space is basically the colour space of the capture device. And a capture device is a bloody camera. Yes, it is. Well, it isn't the camera, it's the sensor that sits in the camera, but seeing as they're not interchangeable, your camera has a colour space. Yes, it damn well does. And let's just temporarily clear this comparison out, and let's go and have a look at the colour space or capture space of a very popular camera, Canon 5D Mark IV. And we've also got a Sony A7R Mark III, which again is quite a popular camera, or at least ways it was. It might have been surpassed now as the most popular Sony camera. But you can see that these camera profiles are quite badly behaved, to be quite honest with you, in extremes. I mean, what on earth this is all about, I don't know. And where do we get these colour spaces from? I actually borrowed, in air quotes, these colour spaces from, or capture profiles, from the 2017 edition of Capture One Pro. And you can see Capture One Pro contains an awful lot of basic camera profiles. It's quite scary. But there you go. So I'll minimise that and come back to here. So let's just go back to the slightly larger one, which is the Canon 5D Mark IV. Good little camera, 5D Mark IV. I've always rated it. And so there you go. That's all personal feelings, but you see, it too has funny little bits on it. You might call it a badly behaved profile. It's not a well-behaved profile, but there again, it's not a profile that you would ever use in your workflow. You only use synthetic profiles, which are very well-behaved because of their shape and their form. You only ever use those, but which one do you use? This is the thing. Which colour space do you use as your working space in your processor? Well, if you use Lightroom, you're stuck with one, which is ProPhotoRGB. And that is the colour space that you use, and you can't change it. If you're in the likes of Raw Therapy, etc., I don't know about Capture One Pro anymore, I'm a bit out of touch with that, but in the likes of Raw Therapy, if you look at open an image in Raw Therapy, you will see that the working space defaults when you install it to ProPhoto. Little caveat here, the previous video I uploaded, which was me prattling around inside of Darktable, I did suggest changing the working space or working profile to ProPhoto. I will be doing a video on this a little bit later this week on my revised setup of Darktable. But the thing is, ProPhoto is not a linear gamma profile. It has a natural gamma of 1.8. But it doesn't really matter what profile you have set inside Raw Therapy. It doesn't read the tone curve of the profile, or the native tone curve of the profile, and therefore, even though it's ProPhoto gamma 1.8, it actually treats it as linear ProPhoto, and that is where I made a bad or wrong assumption about Darktable. I thought Darktable did the same, but it doesn't. The clue was the fact that in the video the picture keeps changing when I move the working profile, but I never cottoned on to that. So anyway, that's enough about that. So we'll just minimise that, and so we'll come back to here. So we have to look at our working space and how it equates to all the colours that are potentially capturable. Capturable, is that actually a word? I don't know. You tell me. But the potential colours that are capturable by your camera. So if we hold that for comparison and we look at ProPhotoRGB, you can see that even ProPhotoRGB is not big enough to hold all the colours that are potentially capturable. There we go, use that word again, by your camera. It will clip camera captured colours, or certain camera captured colours. If you were to use the Adobe RGB colour space, it would clip a hell of a lot more of your colours captured by your camera, and we won't even bother looking at sRGB for that because we just know what's going to happen there. But if we come back to ProPhoto again, you can see that it holds quite a lot of the colours that are potentially captured by your camera. If you're in Darktable, Darktable by default uses Rec 2020, and if I switch out to Rec 2020, you will see that it is a lot smaller than ProPhoto. Therefore, it clips out a lot more of your camera's captured colours. So basically, if you want to maintain the maximum information from the colours captured by your camera, or potentially captured by your camera, you need to use the ProPhoto RGB colour space as your working space for your raw processor. That's if you want to maintain the maximum captured colour range from your sensor. So as you can see, both in terms of input, capture, and in terms of output, print, ProPhoto, being the biggest profile that we are familiar in using, makes the most sense in both cases. Now, there is another colour space. Everybody says, oh, ProPhoto, it's the biggest colour space there is. No, it isn't. Oh, no. Oh, no, 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 no. We have Ace's APO. Oh, gee whiz, that's a monster, that is. An absolute monster. But you see, even that still clips colour out of, say, what is a relatively old camera now, a Canon 5D Mark IV. You can see all these sort of blue greens and all these reddish orangey greens and yellows. They can't be contained within the ACES APO colour space. And what does that look like with ProPhoto? Actually, not quite as bad in the sort of warmer colours and more natural colours of reds, oranges, greeny yellows and greens and reddish purples, etc. It doesn't clip quite so many as ACES APO, because ACES APO really does like greens and blue greens. I mean, it is huge in comparison, but I don't really know of any software that uses ACES APO. I don't. Maybe the video guys do, I'm not too sure. I know there was a lot of talk at one time about using APO as an archival colour space, but it never really caught on as far as I'm aware. So I just stick with ProPhoto and it works for me, and it doesn't do my professional picture production doesn't cause it any trouble or cause any problems for my income, I'll say, on that side of things. So it's plenty big enough for you to handle the majority of colours captured by your camera and the majority of colours, or all of the colours, that you can reproduce as output on your printer. Funnily enough, if we look at the ProPhotoRGB colour space again, and then switch out the view to the YXY and compare it to the spectrum locus of human vision, yes, you can see now you've got a pretty good idea of the greens that are outside of the gamut of human vision and the blues that are outside of the gamut of human vision, and that's what triggers all the people who want to slag off ProPhoto into action. Yes, just as an aside, let's now keep this view but go back and look at the Canon 5D Mark IV, for instance. Wow! Look at the colours that the 5D Mark IV sensor is capable of recording, and look how much outside the gamut of human vision those colours lie. Let's sort of flip it round so we can get a pretty good look. So we're capturing blues that are outside of the gamut of human vision, reds that are outside of the gamut of human vision, and as for the greens, well, you tell me, they're off the charts. I can't shrink this down enough in ColourSync utility to actually get the end of this profile in view. I mean, come on. So, it's all right slagging ProPhoto off because it contains synthetic colours, as they like to call them. They're not synthetic, they're just outside the gamut of human vision, but they are capturable by a bloody camera. So, go figure. This is why you need to use ProPhoto, because at the end of the day, it is just about the biggest, most readily interchangeable between apps, applications, colour space that you can use that will actually keep the maximum number of colours captured by your camera. Now, the other thing about colour profiles is, and I've mentioned it once or twice, gamma. And just to get over this, I'm just going to open up a piece of software that, Krita. I certainly don't use Krita, but Krita does have a really, really useful little routine inside it, and it's this. First of all, you'll notice this picture of this bar now. If we look down here, it's a 16-bit integer. That means it's a 16-bit TIFF, but it is in the linear ProPhoto RGB colour space. And it doesn't make any bloody difference whatsoever on the screen, because the screen is calibrated to Gamma 2.2, and so, this recording is in Gamma 2.2, so basically it doesn't look any different than it would do if it was in ProPhoto Grey Gamma 1.8. It really doesn't make any difference. Screen gamma and gamma correction is a total other story, which you can read about on my blog and on my Patreon site. But if I think I'll put a link to a article on gamma correction that I wrote years ago. I'll put that in the description panel below if I remember. But the useful thing in Krita is this. If I come to image and I go to convert image color space, and then we go color space browser, and let's just extend this out so everybody can see it, and then we'll squeeze it back in so things don't look quite so squished up. There we go. So this is linear ProPhotoRGB. There's the points, including the there's the greens that we can't actually see, and there's the blues that we can't actually see. Big deal, yada yada yada. It makes no blooming difference whatsoever, Mr. Metronic. Oh dear, I shouldn't really have said his name, should I? But well, there you go. But you can see that the profile is a straight up 45-degree slope, 1:1:1, so it is a linear profile. Compare that to ProPhotoRGB, and there it is, original manufacturer Kodak, not Adobe, as a lot of people wrongly think. The ProPhotoRGB colour space is the work of the devil, Adobe. No, it isn't. It was developed by Eastman Kodak. And incidentally, Lightroom uses linear ProPhoto in the background, and in the front GUI, in other words, what you can see, it uses this, which is Melissa RGB, which is basically the ProPhoto numbers, colour numbers, plotted against the sRGB tone curve. Watch this curve. This is the sRGB tone curve, even though it says Melissa. It is the sRGB tone curve, which everybody says is 2.2, and it equates to an overall gamma of 2.2. But if I switch out to Adobe RGB, you see the little subtle changes in the tone curve. That is a gamma 2.2 tone curve. And if I come to Melissa RGB, watch the change in the curve. See it? That is the sRGB tone curve. It equates to an overall gamma of 2.2, but it's different from straight gamma 2.2 in a couple of regions, basically here. All right, so don't make the fatal mistake of thinking the sRGB tone curve is the same as the Adobe RGB tone curve, because it isn't. All right. So if we get back to ProPhoto, and so you can see that if we look at the actual triangle, the dimensions or principal points of the colour space do not change. These areas here correspond to a colour sweep, a little bit like that diagram I showed you of the CIE gamut of human vision when we were looking at the areas, yellowish greens, etc, etc. These represent key points in the actual key known points of colour within the colour space itself, and you can see on the gamma 1.8 how those points are spread out. If we work with the linear version, they're a lot closer together, so we can sort of spread them out a little bit in our workflow. And that is why we use a linear ProPhoto in Lightroom. We use ProPhoto but ignoring the tone curve and therefore treating it as linear in raw therapy. And this is why I now recommend switching to linear ProPhoto in Darktable. So anyway, I'll be doing another Darktable video next, but I hope that's sort of giving you a sort of a bit more understanding of colour spaces, and why you need to take things into account, such as the colour space of your camera, or the capture space if you like, and the output colour space of your printer if you are doing printing, and how to maximise the bang for your buck on your printer and your bang for your buck on your camera by using the ProPhotoRGB colour space for both your working space, as long as it's in linear gamma, and in gamma 1.8 it's native gamma when you're actually doing it as exporting an image to a printer. Okay guys, hope that's proved useful, hope it's proved interesting to you. Thanks to all my Patreon members for your continued support. I couldn't do this without you, and until next time, stay safe, stay well, keep taking the pictures, and I'll speak to you very soon. Tooroo.